Hello, folks, your favorite part of the chapter, the study guide tutorial videos. Here we go. The first question on your study guide, remember this is what I'm giving you on your test, exactly how this looks. A blank unit circle with the degrees and radians. So your responsibility is to complete it. Now, I'm not going to grade this on your test, but it will be made available to you for you to go ahead and fill out the unit circle very quickly before you take the test and then use it as a reference throughout your test. So we're going to complete the unit circle with each angle's coordinates in the set of parentheses first. So if I want to put the coordinates, again, I like to do my four corners first. So I know at 0 I've got 1, 0. And then up here at 90 degrees, I've got 0, 1. Then to the left, I've got -1, 0, and then 0, -1. And then I like to do all my 45-degree angles because I know those are square root of 2 over 2. In the second quadrant, I know x is negative square root of 2 over 2. In the third quadrant, they're both negative. And then in the fourth quadrant, the x is positive, and then the y is negative. And then if I do my 30-degree angle next, I go to the right further than I go up. So that's going to be square root of 3 over 2 to the right, and then just up 1/2. So then that's going to be the same thing as 150, except it's going to be negative square root of 3 over 2, positive 1/2. Then both will be negative at 210. And then positive square root of 3 over 2, negative 1/2. And then the 60-degree, all my remaining four angles are going to be swapped. It's going to be 1/2 first, then square root of 3 over 2. So it'll be negative 1/2 square root of 3 over 2. Negative 1/2, negative square root of 3 over 2. Positive 1/2, negative square root of 3 over 2. Okay, so those are all of my coordinates. The second thing I want you to do, it says, is fill out the simplified value of the tangent at each angle. So this is something that you can find easily, very quickly, but it's also beneficial if you, excuse me, just know what the tangent is at each point as quickly as you can tell me what the coordinate is at each point. And there's kind of a pattern to it. So again, at my horizontal line here, I know that tangent is 0. At my vertical line, I know the tangent, y over x is 1 over 0 and negative 1 over 0, which since we can't divide by 0 is just going to be undefined. The other easy ones for tangent are the 45 degrees, because when I do square root of 2 over itself, I get a slope of 1, which is going to have the same slope as 225 degrees because that's that positive slope of a line there. And then the other two 45-degree angles from the x-axis are going to be a slope of -1. Okay, so all those are going to be pretty easy. The only ones that we'll have to do a little bit of work on is like the tangent of 30 degrees. So at my 30-degree angle, tangent is y over x. So that's going to be 1/2 over square root of 3 over 2. Well, when we divide stacked fractions like this, we're going to keep our first fraction 1/2, and then we're going to multiply by the reciprocal. So we're going to multiply by the reciprocal will be 2 over the square root of 3, which will be 2 over 2 cancels, and then we get 1 over the square root of 3. Sometimes you might see it written like this, or if you go ahead and rationalize it, it'd be better, you'd see it as the square root of 3 over 3. So the tangent of 30 degrees is the square root of 3 over 3. It will have the same slope as 210 degrees, square root of 3 over 3. It will have the negative slope of, again, they all go with the bow tie. It will have the negative at negative 330 degrees, so it's negative square root of 3 over 3. And at 150, negative square root of 3 over 3. And then the last one will be the tangent of our 60-degree angle. Y over x will be square root of 3 over 2, over x will be 1/2. So we're going to multiply by the reciprocal instead. So keep the square root of 3 over 2, change the operation to multiplication, and then reciprocate 1/2, which is 2 over 1, and you end up with the square root of 3. So the tangent at 60 degrees is the square root of 3. It's going to be the same as 240 degrees. And then the other two are going to be the negatives of that because that has a negative slope. So if you fill this out at the beginning of your test, this will be able to give you some, shed off a lot of time from you having to actually solve this on your test when you can reference it on your circle. Number 2, write the general form of each type of coordinate in the real numbers. So when I say coordinates, I'm looking for parentheses with our two elements separated by a comma. So rectangular coordinates, those are the ones that we're used to. Just regular x, comma, y. A polar coordinate is going to have the variables r, comma, theta. So for number 3, I want you to graph each point. Obviously, these are polar coordinates. So r kind of stands for radius, but not exactly because it can be negative, and you can't have a negative radius on a circle per se. And then, of course, your second coordinate is theta, and that's kind of the approach that you want to take is you want to find your coordinate, or you want to find, your angle first, and then from there graph r. So negative 3 pi over 2. Well, positive 3 pi over 2 is down here. So that would be if we started at 0 and we went all the way around, this would be positive 3 pi over 2. If I go negative 3 pi over 2, that means I'm still starting at 0, but I'm going to go the other direction this amount. So negative 3 pi over 2 is actually going to be the same thing as pi over 2. So this is the angle. This is the same thing as negative 3 pi over 2. Once you locate the angle, since r is negative, instead of starting from the pole and counting 3 toward that angle, I'm going to go 3 in the opposite direction. It'll be 1, 2, 3. So this will be point M. Part B, 585 degrees. First of all, notice, 585 is not on our unit circle. So the first thing we want to do is take 585 minus 360, ends up with 225. Well, 225 degrees is not on the unit circle per se, like we don't see that number, but it's actually going to be between 210 and 240. So that's going to be 225. So again, that's the perk of filling out your unit circle before the test, because this one is on a regular unit circle, not necessarily this example polar graph. So toward that angle, I've got an r of negative 2. Instead of counting 2 in the direction of 225 degrees, I'm going to count 2 in the opposite direction. And there will be point S. And the last one, like this, example C. My angle is 5 pi over 4. Well, let's talk about positive 5 pi over 4. Positive 5 pi over 4 will be this angle here. Well, we want to go that same distance, but we want to go clockwise instead of counterclockwise. So if we start at 0 and we go that same distance over here, negative 5 pi over 4 is going to be that angle right there. And then r is 3, so that means from the pole, since it's positive, I'm going to count 3 toward that angle. And then plot point V. Make sure you label your points. Okay, number 4, point D has coordinates 1, 3 pi over 2. Name 3 other points between 0 and 2 pi. I should have specified that I want the equivalent values of 1, 3 pi over 2. So I essentially want 3 other ways that you could name this same point. I don't want 3 other random points. Additionally, I guess this technically should be between negative 2 pi and positive 2 pi. So the first thing we want to do is actually graph the point. That way we know what we're looking at here. 3 pi over 2 will be this angle down here. And r is 1. So I'm going to go in the positive direction toward that angle. So there I have point D. Our job is to name this point in 3 other ways. Well, we said instead of starting at 0, starting at 0, we can go to the positive 3 pi over 2, but I can get to this same angle if I start at 0 and I go clockwise a distance of negative pi over 2. So there's another coordinate. Instead of calling it 1 3 pi over 2, I can call it 1 negative pi over 2. So that takes care of, you're going to have 2 options that have a positive r, and you're going to have 2 options that are going to have the r but in the negative version. Okay, so those are the positive r's. If I'm going to have r be negative, that means the angle that I'm going to go for is pi over 2. Because if I have an r, it won't go in this direction because it's not going to be positive. I'm going to have to go in the other direction, which will get me point D. Okay, so another option is if I do -1 and then pi over 2. That means at pi over 2, I go the direction of -1 and then I get point D. Instead of calling this angle positive pi over 2, I can refer to it as negative 3 pi over 2. And that's my third and final representation, -1, negative 3 pi over 2. So these are 3 equivalent ways to write the coordinate point D. Number 5, graph r is equal to -2. You got to think about what this means. There are an infinite amount of polar equations that can have an r value of -2. So you're not just graphing one point, you're graphing a whole slew of points. -2 means you're going to start at the pole and you're going to go 2 in the direction opposite your angle. Well, we don't really know where that angle is, right? So we don't really know where opposite is. All I know is that wherever I am from the pole, I'm going 2 out all over the place. So 2 away from the pole on the entire polar coordinate plane would look like a circle with a radius of 2. Okay, same idea for number 6. I want you to think about what this means. Graph theta equals -2 pi over 3. This is saying I want the representation of all the possible equations where theta, our angle, could be -2 pi over 3. So the thing to make sure of here is, first of all, we want to locate where that angle is. Well, notice positive 2 pi over 3 is right here. So that means if I start at 0, that would be positive 2 pi over 3. So if I want the negative version of that, it's going to be the same thing as 4 pi over 3, right? If I go that same distance, then 4 pi over 3 is going to be the same thing as that. Okay. Then what we're representing is all of the equations that could possibly have this as theta. And when we do that, we're actually going to end up with a line that goes through the pole and all the way to the opposite side. So anytime you graph r equals something, think about that as the radius of a circle, and it's just how big your circle is. Anytime you have theta equals something, you're actually going to end up with a line. Number 7, these are going to be equations that you need to be able to generate and use very quickly on your test to transfer, or what's the word I'm looking for? Convert from polar back to rectangular form. X is the same thing as r times cosine theta. Y is the same thing as r times sine theta. R can be defined as the square root of x squared plus y squared. And we have 2 options for theta. First option is that theta could equal tangent inverse of y over x for when x is greater than 0. And theta could equal tangent inverse of y over x plus pi, and this is used for when x is less than 0. So again, you need to be able to come up with these and know when and how to use them to convert back and forth between rectangular and polar coordinates.